Hi everyone, it's Tarulli Tutoring here. Today we're going to be tackling the grade 12 advanced functions math concept known as the sum and difference of cubes. So let's get started. Before we get into what the sum and difference of cubes actually is, we want to recall this formula from grade 11 and grade 10 math that we know as the difference of squares. We see something like a squared minus b squared, and we know that we can express this in the form of a plus b, a minus b, if we want to factor it. Something we should be familiar with by now, and I just want to review this, because this concept kind of builds on this. So when we have the sum or difference of cubes, we have something very similar in that we have a cubed minus b cubed, and this is for the difference of cubes. And then we also have a cubed plus b cubed, and this is for the sum of cubes. Now you might be asking yourself, well, we have this sum of cubes. We never had a sum of squares before. We weren't able to factor something in the form of a squared plus b squared. And you are correct. But we're actually able to factor something that is the sum of cubes because we have an odd power. Whenever you have an even power and you're summing the two terms, you are not able to factor those two things. But in this case, we can actually factor something that is the sum of cubes because we have an odd power, which is 3. So in case you're wondering, I'm not going to get too much into why we can't factor this. You'll get more into this later when you get into higher level math about, real roots and imaginary roots and whatnot, but I'm not going to spend too much time on that. Just know that we cannot factor this. With our limited knowledge right now, we can't factor this, but we can factor this right here, our sum of cubes and our difference of cubes, and that's what we're going to get into right now. So just like our difference of squares, we have a formula for our sum of cubes, and we have a formula for our difference of cubes that we can apply to be able to factor. So let's go through what those formulas are now. For our difference of cubes, if we have a cubed minus b cubed, our formula would be a minus b, and then we're going to have a separate bracket where we say a squared plus ab plus b squared. So that's the first formula. Second formula is as follows. We have, for our sum of cubes, we have a cubed plus b cubed equals a plus b, and then we have a squared minus ab, and then plus b squared. So those are our formulas. Now, the next thing we have to do is go through some examples, because showing a formula is nice, but really we need to be able to practice our knowledge and see how this applies to actual examples. So let's do that now. Okay, so here in this example, we have x cubed plus 8. We can see from this nice addition sign over here that this is going to be a sum of cubes. So we're going to want to use the formula a cubed plus b cubed is going to be equal to a plus b, and then a squared minus ab plus b squared. So that's the formula we're going to want to use. So we know that obviously x cubed is going to be a, and 8 is going to be b cubed. So we would know that if we take the cube root of 8, we get 2. So very important for us to know to be able to apply this formula. This is something we should probably be aware of by now, that 2 cubed is 8, but just in case you don't know, you could go through and take the cube root of 8 to find that out. Anyway, continuing on, we would now factor this and say that we have x plus 2, and then we would say x squared minus, and then we would say 2x, and then plus 4. And that would be it. That's how we would factor this. That would be the answer for this first problem. All right, now let's go and do a second example. Okay, here in this example, we have x cubed minus 27. We're going to want to factor this using the difference of cubes formula, which is a cubed minus b cubed equals a minus b, a squared plus ab plus b squared. We're going to want to use this formula. We also want to identify that, of course, x cubed. We know that just x is going to be the cube root of that, and then 27 is 3 cubed. So we're going to be using 3 when we expand and factor this formula. Okay, so now let's factor this. Okay, so we would say that our a is x, so we have x, and then we already said that b is 3, so we have x minus 3. A squared is going to be x squared plus ab, that's going to be 3x, and then 3 squared, that is going to be 9, so we're going to say plus 9. And that's it, that's how we would factor this. Really not that complicated. We just need to break down everything into what we need and then apply the formula, and then we're able to factor this. Okay, let's look at another example. Okay, so looking at this example on first glance, you might think, well, we can't factor this using sum or difference of cubes because, well, it's 2x cubed plus 2. We would need some kind of funky cube root of 2, and that's not a perfect cube, so why would we want to factor this using difference of cubes? But what we always need to remember is that when we factor anything, even if we're using sum or difference of cubes, using difference of squares, any kind of cool shortcut factor technique, we have to remember to remove the GCF first. We always want to remove the greatest common factor first. So if we look at this right here, this expression here, and we do that first, we remove the greatest common factor, which in this case is 2. We say 2x cubed plus 1. We are left with this on the inside, this x cubed plus 1. And we most definitely can factor that as a sum of cubes. We have to remember to keep this 2 on the outside. We can't get rid of this 2 by any means, but we can actually factor this inside part now using our sum of cubes. So let's do that. Again, we're keeping our 2 on the outside. This is a sum of cubes, so we're going to say x plus 1. Then we'll say x squared minus x plus 1. And that's how we would factor this. This is the answer for that. All right, let's do another example. Okay, so looking at this expression here, this is actually going to be our last example. I think this is probably one of the hardest examples you could get. So let's just go through this and then we can, close the door on this topic and move on to other things. But we are going to look at how we would factor this. And again, you might look at this and might think, we can't use the sum or difference of cubes here because we don't have the right powers. We need something with a cube. We need something to the power of 3. And that is not always the case. I don't want you to confine yourself to that way of thinking. If you look at this, you see x to the power of 6, that's the first term. We can express this as x squared times x squared times x squared, right? And because of our exponent laws, when we're multiplying all of these, we will be adding the exponent. So plus 2 plus 2 plus 2, that gives you x to the 6, right? Well, basically, we have said that x squared, if we cube that, we get x to the 6. So we're going to use that when we're solving this. Same thing with y to the 9. Y to the 9 can be expressed as y to the 3, comma, y to the 3, times y to the 3 times y to the 3, right? And then because of exponent laws, we're going to add up all of these powers and we get y to the 9. And again, we're going to be using this in this formula. Because basically what this is telling us is that our a would be x squared, and that if we were to factor this using difference of cubes, our b would be y cubed. So let's apply that knowledge now to factor this. Again, we would start off and we would say that we have, this is a difference of cubes here, so we have a minus b, and then we're going to say a squared, and then plus ab, and then plus b squared. All right, so if we sub in what we know now, that a is equal to x squared and b is equal to y cubed, we would say that we have x squared minus y cubed, and then x squared squared, so if we have this over here, that gives us x to the 4th, so x to the 4th plus x squared y cubed, and then plus we have y cubed squared. That's going to give us y to the 6th. So plus y to the 6th. And that's how we would factor this. All right, so that concludes this topic of sum and difference of cubes for grade 12 advanced functions. If you have any questions at all, or if you'd like additional examples, please let me know and send me an email at Tarulli Tutoring at gmail.com, and I will try to get back to you, or you can just comment down below and I will do my best to respond to you as soon as possible. Thank you for all your support, and I'll see you in the next video. Bye.